All right, let's dive into a true legend in the history of secret codes, the Vigenère Cipher. For a long, long time, this thing was considered the absolute peak of encryption, a cryptographic monster. But, as we're about to find out, every legend has a secret weakness.
And I'm not kidding about its reputation. For centuries, it was known by its French nickname Le Chiffre Indéchiffrable, literally the unbreakable cipher. For code breakers, it was a total nightmare. A message locked with this cipher just looked like a random mess of letters. There was no obvious way in. So what made it so incredibly tough?
Well, this is where the Vigenère Cipher was a huge leap forward. You see, simple ciphers like the one Julius Caesar used are predictable. They just shift the whole alphabet by a set amount, so an A always becomes, say, a D. Easy. But the Vigenère Cipher uses lots of different alphabet shifts, all in the same message. That totally scrambles the letter frequencies that codebreakers depend on to find patterns.
So how does it juggle all these different shifts? The secret is surprisingly simple and pretty elegant, actually. It all comes down to one single secret keyword. That little word is the engine that powers the whole thing.
Now, the key thing to get here is that the keyword isn't just a password you type in. Each letter in the keyword represents a number. A is a shift of 0, B is a shift of 1, C is a shift of 2, and so on. So if your keyword is lem, you're telling the cipher, first shift by L, then shift by E, then shift by M.
And this shows you exactly how it works in practice. Let's say our message is attack at dawn, and our secret keyword is lemon. You just write the keyword over and over again underneath your message. So lemon becomes lemon, lemon, len, lining up perfectly with every letter you want to encrypt.
The encryption itself is just a matching game. You take the first letter of the message, A, and you match it with its key letter, L. That gives you your new encrypted letter. Then you do the same for the next pair, T and E, and on and on. In this case, that first A gets shifted by L and becomes an L. The next letter, T, gets shifted by E and becomes X. You just keep doing that all the way to the end.
And there you have it. After we run our whole message through the lemon key, attackadon turns into this string of what looks like pure nonsense. L, X, F, O, P, V, F, R, N, H, R. If you don't have the key, this is just gibberish. You can see why people thought it was unbreakable for so long.
But here's where the story takes a turn. Because, well, no code is really unbreakable forever. That amazing reputation, it eventually started to crack, once cryptanalysts figured out the ghost in the machine.
I mean, this was the big question, right? If the letter A can turn into an L here, but a P over there, and a V somewhere else, where do you even start? How do you find a pattern in what looks like total chaos?
The fatal flaw was hiding in plain sight. It's the very thing that makes the whole system work, the repeating keyword. Because our keyword lemon is only 5 letters long, that sequence of shifts starts all over again on the 6th letter of our message. And as soon as the key starts repeating, subtle patterns can start to appear in the encrypted text.
And this weakness was famously cracked by looking for those repeated patterns. Think about it. If you see the same 3-letter chunk of gibberish appear twice in your ciphertext, that's a huge clue. It probably means the same part of the message was encrypted with the same part of the keyword. By measuring the distance between those repeated chunks, codebreakers could guess the length of the keyword. And once you know the key is, say, 5 letters long, you're not solving one impossible cipher anymore. You're solving 5 simple ciphers. And that is way, way easier.
And that's why the Vigenère Cipher is kind of a ghost in the world of cryptography. Nobody uses it for serious security today, but its story teaches us one of the most important lessons there is about what makes a code truly secure.
The Vigenère Cipher relied on being confusing, what we call security through obscurity. Modern encryption, the kind that protects your bank account, works totally differently. Its security is based on incredibly hard math problems, problems that are basically impossible to solve without the key, even if you know exactly how the algorithm works. The Vigenère Cipher's big mistake was using a short, reused key, and that's a lesson that's built into the very foundation of modern cryptography.
This actually brings us to a really cool idea. The only provably 100% unbreakable cipher is something called a one-time pad. It's basically a Vigenère cipher with a few strict rules. The key has to be totally random, it has to be at least as long as your message, and, this is the most important part, you can never ever use it again. The Vigenère cipher's method was sound. Its weakness was all in the reusing of that short little key.
So, the whole story of the unbreakable cipher really leaves us with this one crucial question to think about. It shows us that just making something complicated isn't the same as making it secure.
Real security comes from understanding and getting rid of patterns, not just trying to hide them. And that's a lesson that's more important today than it has ever been.